Hello guys, welcome back, Cost Electronics. Here is the module from the Porsche Cayenne, the trailer module, and I want to do some measurements on my desk. Here the wiring diagram that we see in the other video. I connect power and grounds and do some measurements. Wires are installed, ground and two positive wires, one permanent and one switched. I connected A16 and B2 and B1 for the ground. The other powers are not necessary to power up this module because they are for the accessories of this module. I mean the external components. Power on, 40 milliamps, that's okay. Now for the first I want to check this oscillator here. And as you can see, it swings, but it has glitches. Can you see this? It's not constant. This is not good. Let's check the power from the processor. This here is the 5-volt supply from the regulator here that goes directly to the Motorola. Oh, I have to change the scope settings to DC. Try again. Out of range, moment. Five volts there, constant, no problem. So, what's the reason for these glitches? I think next thing I want to do is check the reset pin of this Motorola here. Here you can see the type, what it is. Let's find the data sheet on the internet and check the pins. Here we go. Oh, sorry, my lamp. Where is the reset pin? First, anyways, check the power again. Pin 21. VSS, sorry, this is ground. Pin 22 is VDD. Check for nice and smooth power on this pin. Nice and smooth, 5 volts, nothing wrong there. Now go for the reset pin. This is pin 3. 1, 2. Oh, it's on the camera. Can you see? Reset. That's not normal. Why? From where comes this reset command? From the Motorola itself or from outside? Interesting. I think next thing I'm gonna do is lift this pin and see what happens. Pin 3 is lifted up in the air. First I check outside the processor. Whoa! It's not the processor, it's from outside that it looks. Check on pin 3 from the processor now. Oops, sorry. It's constant low, no wonder. And the oscillator swings constant. Wow! Something with this reset circuit on the PCB is wrong. But what? We will find out to understand what happens here. If you press on your reset button from your home computer maybe, the system permanently resets and resets and has no chance to boot up. And this is the same what happens here. Something permanently resets this controller, this Motorola. And in this way the processor, the Motorola, has no chance to boot up. But why does this happen? I have to find out. This is another time-based setting on the scope, and as you can see, the reset is very constant, and this scares me a bit. Why is this processor being resetted from outside in such a constant period of time? I have to find which component here makes the reset from this Motorola and go from there. Okay, if I trace the route from pin 3, which is the reset from the Motorola, I'm landing on the other side on this chip, pin 5. As you can see, exactly the same. Now, this chip here causing the reset from the Motorola. And I have already opened the datasheet, and it's a watchdog timer. Uh-oh. Read the description. Especially this sentence here. Nominal microcontroller operation is indicated by a cyclically transmitted trigger signal which is received by a window watchdog timer within a defined period time window. A missing or a wrong trigger signal causing the watchdog timer to reset the microcontroller. I think this is what happens here. This trigger signal maybe is missing, and this watchdog chip here constantly resets the Motorola. So let's see what the pin assignment is. Here is a block diagram from this watchdog, and as you can see here, the microcontroller, this is the Motorola. Pin 5 is the reset, and on pin 2 I should see a periodically repeating signal. If this signal is missing, this logic here constantly resets the Motorola. Okay, pin 2 and 5. On channel 1 is the reset. On channel 2 is the trigger signal, which should comes from the processor. And here is definitely something, but I can't say if it's correct or not. I have printed out the complete datasheet of this watchdog. Now, I want to explain how it works. All timing events are based from this internal RC oscillator. The internal frequency is set by two external components, this resistor and this capacitor. And here is a formula to calculate how long is a time cycle. I have already calculated with these values that I have on my print, on my PCB I mean. So one timing cycle takes 29.77 microseconds. Another thing, here are the description for each pin. Only, this is not important at the moment, but I want to say, this enable output here goes high after 3 correct trigger events from the Motorola. So now this here is important. This is a correct sequence of all the signals that must be in time that this watchdog is happy. Now here are time labeled T0, T1, T2, T3 and so on. And here in the data sheet are the typical cycles for each time. Example for T0, it takes normally 201 cycles. Also for the rest of all the times. Here, before, I have calculated one cycle takes this time. If we want to know how long, for example, this time here takes, I write it down here, 201 cycles. 201 multiplied by this time here, T0 takes 6.7 milliseconds. T2, 130 cycles, 4.3 milliseconds, and T3, 4.1 millisecond. Now, let's explain this chart here. After the supply voltage of the watchdog goes high, it takes this time here 6.7 milliseconds until the reset output goes high. And then this time here starts T1. Within T1 the mode output from the Motorola must go high. It must go low. When the mode output is low, the watchdog waits for a trigger. So then starts T2. T2 is the dead time. In this time should no trigger is no trigger allowed. If one trigger comes here, the watchdog makes a reset. So the trigger must come after T2 within the time T3. In this time here. Here the watchdog expects a trigger. If this appears, another cycle starts with T2 from here. So this sequence here repeats and repeats and repeats. If one cycle, if one trigger is missing, the watchdog makes a reset. Now, let's check this with my picoscope. I have set up 4 channels. Here, on channel 1, the reset output, on channel 2, the trigger, channel 3, the mode input, and on channel 4, the enable. I make 2 measurements. One time with enable on channel 4 and one time with the supply voltage on channel 4. So, let's do the supply voltage test first. Then I should see a pattern like this. Let's do this. Okay, the picoscope is set up, 4 channels, 0 to 10 volts. Here are the channel names. Let's fire up. We can see something. Pause it. So now let's go to the start of all the events. Here it starts. The top line is the supply voltage exactly according to this diagram here, and the blue trace is the reset. Zoom in more. Now let's measure the time between the supply voltage appears and the reset goes high. It should be 6.7 milliseconds. Let's see. One cursor here, one cursor there. Not bad. Here we have a delta 6.5. This is not way out of range. It depends where it switches. I think this time is correct. This is in range. Now the next sequence from reset out. No, this is not important. If the mode after the mode goes high, T2, 4.3 milliseconds. In this time no trigger should come. Let's check. Here is the mode goes low, like this here, and now go forward 4.3 milliseconds. Exactly in time. Next, from here 124 cycles, that means 4.1 millisecond. About this, now we are here in the dead time after the first trigger. We are again here on T2. In this time no trigger should appear, which is correct. Now go for the next trigger event. Again 6.7 milliseconds. Exactly. This trigger is in the right time. Perfect. Now scroll further. Here the next reset event happens. Why? Let's check if the enable output goes high, like it's described here on pin 3. No, enable here. It's activated after the processor triggers 3 times correctly. Now I'm doing the second measurement on this channel, on this pin 4 here, enable. Moment. So here we are again on this channel here. The all bottom one is the enable output, and as we can see, a moment, I move it up. Exactly after 3 trigger events, this output goes high, as it should. So everything seems to be normal with this watchdog. But in the meantime, take a close look at this picture. Can you see something? Let me know in the comments down below and wait for the next video. Thanks for watching. Bye bye.